Alrighty, can you guys hear me?
Yes.
So it's great to finally have some chance to interact during the lecture. Are there any questions before we get started? So again, the video from last week is up on YouTube, and the links on Canvas.
Good morning.
Good morning. Those of you so I hope everybody has watched it, and if you have any questions about it, you're welcome to ask now, or you can also ask later if you want to. We have office hours every week, and we're going to have them this week too. If not, then I'm going to get started on the second lecture. The the lecture we did last week was out of Hall's book, and so last week we did bonds, we did forwards, we did futures, and this was all out of Hall. And so today we're going to do options, and we're actually going to do pricing. Before we were talking about these quantities, like what is a bond, what's a forward, what's a future. Today we're going to talk about options, and we're actually going to do pricing. And this here is out of Shreve. So we're going to be alternating between Hall and Shreve throughout the semester. There's a lot more math in Steve Shreve's book than there is in John Hall's. On the other hand, John Hall's book has more basic description of the various like assets, like bonds, forwards, futures, options, and so on. Okay, so the starting point here is what's called the binomial model. So we're going to be looking at a binomial model, and this here is going to be a one period. We'll see multiple periods coming, and of course ultimately we're going to be doing this in continuous time, in particular in 622 and 623. So what should we so there's a random variable that controls everything. So there's a key random variable, which is denoted by psi. This here is a psi, which is not spelled chi, it's spelled psi. Spelled xi. So if you write MATLAB, it's this backslash xi. It's a psi. So what is a psi? Well, it's a random variable that can take two values. That's why it's called binomial. So it's a key random variable. The probability that psi takes the value u is equal to p, and the probability that psi takes the value d is then equal to 1 minus p. And p here, for p being some number between 0 and 1. Right, so we refer to this p here as the probability of up. U and D stands for up and down. So we refer to this P as the up probability. also sometimes called the probability of tail of heads. Very often we'll think about psi as the outcome of a coin flip. The coin might not be fair, it might be a bit bent, so the probability is not necessarily a half. So we also call psi a coin flip. So psi is also called a Bernoulli. Or a coin flip. You're not, P is not always a half. This is a Bernoulli random variable. U and D, on the other hand, are just two constants. These are ups and downs. U and D, the probability of being up and probability of being down, these up and down quantities, U and D are constants. So this is the key, this psi here, if I could write it so we can all read it. This here is called psi. So this is our key random variable in a one-period model. So if we were to have a two-period model, we will have two of these psis. If we would have an n-period model, we will have n of these psis, and so on. Okay, so how do we create the binomial model? Again, the word binomial, it comes from the fact that there are two possibilities of psi. It can either be u or it can be d. Well, so then our model, our stock model. So we model the stock price as a tree. So we have time down here on the x-axis. So this here is time. So we're going to have time 1 and we're going to have time 0. So right here, this is where the stock price is today. This here is today's stock price. We call that for S0. This is today's stock price. So when I talk about today, this means time 0. Today's stock price. And then we have the future stock price. We could call that tomorrow or some point later. There are going to be two possibilities in the binomial model. The stock price, wherever it is, it can either go up or it can go down. So you can go from S0 and it can go up, or it can go from S0 and it can go down. And what controls whether it goes up or goes down is this random variable psi. And so if it goes up, that means that it goes from being S0 to being S0 times this variable times this coefficient u here. This happens if we get heads, if psi is equal to u. And the other one is, well, it's either going to be u or d. And so here we'll get S0 times a d. Alrighty, so this is the first time you're seeing the binomial model. It's the stock price. You start out with today's stock price. Then over here, you're going to have the future stock price. So that could be tomorrow's. So this is t equal to 1 stock price. So the big difference is that today you know what the stock price is, but tomorrow you don't know what the stock price is. It has, in this particular model, it has two possibilities. Either it goes up or it goes down. Right, so u here is bigger than 1 and d in this example here is less than 1. Are there questions on this picture here? Any questions on this picture? That makes good sense to everybody. Okay, so now we're going to move on, and we're going to say that in addition to the stock, we also have a bond. There's also a bond. There's also bond trading. And in this particular case, this is also called a bank account or a money market account. In this particular case, there's also a bond trading. And the difference between the bond and the stock in the binomial model is that if I look at the bond price, we're again going to have time, and then we're going to have t equal to 1. We're going to have t equal to 0. For the bond, we will say that the bond price today, this is just $1. And then the bond price at the end, so this is today's bond price. That's today's bond price. And then the bond price tomorrow is going to be, there's only going to be one possibility. And that is going to go from $1 to 1 plus R, where R is our interest rate. So this here is going to be tomorrow's bond price. You put $1 into your bank account, and it's going to grow with the interest rate R. So there's also bond trading with interest R over the period from time 0 to time 1. So the investor, so our investor or our trader, he can buy and he can sell. He can buy and sell the stock and the bond. So if he buys the bond, that costs 1. So if he trades the bond, this is going to cost, this costs $1 at time 0. And if he trades the stock cost is $0. This one cost $1 is 0 at time 0. So if he buys the bond, then the value of the bond at the later time is going to be 1 plus. If he buys the stock, then the stock at the later time is going to be either S0 times U or S0 times D. Are there any questions about this? Any questions about the two securities we're looking at so far? So the first order of business is this arbitrage, this notion of arbitrage. We have two models. Maybe we should look at a specific example. Maybe we should look at a specific example and then talk about arbitrage in this specific example. Let's do an example. We're going to say that S0 is equal to 4. We're going to say that U is equal to 2. And we're going to say that D is equal to a half. So then when we look at the stock, you're going to have a picture that looks like this. So we're going to go from $4 today, and then you can go up to 4 times 2, that's going to be 8 in the future. Or if you get tails, you're going to go to 4 times a half, so that's going to be equal to 2. Right, so again, this year's at time 0, this year's at that future time, which we call tomorrow. So this is the stock. And now what about the bond? Where should we put the bond? And the bond is over here. That goes from 1, and then it goes up to 1 plus R. This is the bond of the bank. One question could be, what kind of values can I allow for R here? What kind of values? What values of R? What values of R rules out this arbitrage? So that's a new word that we haven't. I'm sure some of you have heard about arbitrage, but arbitrage, this means in words, this means you can make money. You can make money with no risk. Okay, so let's try to do an example. What could we, for example, how could we have a model that would violate, that would produce an arbitrage? Well, you see, the starting point here is 4, and this one here is 1. Okay, so one thing I could do, I could try to bring it up to the same scale so that you would start out both at 1. So I could multiply. I could buy 4 of these. So if I buy 4 units of the bank or the bond, then what I would have happen is that it would go from, instead of 1, it would go from 4, and then it will become 4 times 1 plus R. I'm going to stop writing these dollar signs, it's too much. It's going to write 4 here. Okay, so now they start out at the same time. If you start out at the same point, 4 and 4, where should this number here be? How should this endpoint 4 times 1 plus R relate to these two values, 8 and 2? Any guesses?
Would it be R less than 1?
R less than 1. Okay, so R less than 1, this will give me that 4 times 1 plus R is less than 8.
Yes, that rule out arbitrage.
So we'll have, so this is, so here's our claim. You need 4 times 1 plus r less than 8, less than or equal to.
It would have to be, well, I guess less than or equal to, because if you break even, that's not arbitrage.
Okay, so we have, so there are 2 possibilities. Okay, let me write them down and we will go back and have a discussion about them. So here's suggestion 1. Less than 8, and suggestion 2. 4 times 1 plus r less than or equal to 8. I admittedly, this distinction is not a very big one. There's not that many values of r that will make it exactly equal to. Okay, so that's suggestion 1. That's suggestion 2. Should we have other suggestions? What about the lower bound? There was a question in the chat. We want equality. Okay, so suggestion number 3. Suggestion number 3 says that we should have 4 times 1 plus r equals 8p plus 2 times 1 minus p. So that one takes care of both upper and lower. Kenneth, was it you that suggested 1 and 2? Can you also provide some lower bounds here, maybe?
Oh no, it was me. Yeah, the lower bound would be 4, because the initial price is 4, and you don't want to go below that.
Yeah.
So
So you want to put a 4 here?
Yeah, I think. Yeah.
Okay, and you want to do it with both suggestions?
Yes.
Okay, so the key to do this is you have to look at these 2 pictures at the same time, and then merge them. And if you merge them, then the question is this 1 plus r, how does it relate to 2 and how does it relate to 8? So I don't like the 4 here. I don't like the 4 in these 2 spots. I like the 8, and then we can always have a debate about whether it should be strictly or strictly, whether it should be less than 8 or strictly less than 8. But the 4 here I don't like, because what we're looking at here is the 2. So I don't like these 4s here. I would suggest that we put a 2 there instead. So let me do that. And then we have the other one that involves a p. So I can see why this is tempting. It is tempting to put a p there, because what you have here on the right-hand side, this is the expected value of s at time 1, right? There is a probability of of going up is p, and the value you get when you go up is exactly 8, and the probability of going down is 1 minus p, and the value of going down, this is exactly, that's going to be exactly 2. But keep in mind here, it says no risk. It says no risk. So there's no p. This here, what this is going to mean is that there's no p. This one here, there is no p. There's no p because of the no risk. This is the no risk aspect. But remember, of course, that beyond the requirement that p is between 0 and 1. Okay, so let's try to do it. Let's try to do an example for R where this thing fails. And then we can see how we should set it up. And then I'll write the correct condition at the end. So say we have a picture, say we have R such that, this is my 4, it goes up to 8, and it goes down to 2. And now say that you have an R which sits like this. So R goes high up here. Say that you go up to 4 times 1 plus R. Then what would you do? Then the arbitrage strategy. So ARB, this is just short for arbitrage. The ARB, it exists. What are we going to do? Do you want to buy or sell the bank? And do you want to buy or sell the stock? Which one should we buy? And which one should we sell? Should we buy the cheap one or should we buy the expensive one? Should we buy the red line or should we buy the pencil?
Sell the higher, buy the lower.
Yeah, so we should buy the
8.
So in the chat we're saying we should. In the chat we're saying we should sell the stock and buy the bond. Okay, so sell the stock. Sell the stock. This is going to give us. This gives us $4 at time 0. And then we should sell. So we sold the stock. That gives us the $4. And then we're going to buy the bond. This is going to cost us $4 at time 0, right? So the net, this is net at time 0. Well, we're buying the bond. Okay, so we're buying the bond. This costs us $4, and we want to sell the stock. This is going to give us $4. Okay, so the net at time 0 is $0. So this strategy doesn't cost us any money at time 0. Now, what about at time? So this here was at time 0. What about at time 1? So at time 1, what happens at time 1? Well, we bought the bond. So we're gonna get 4. So dollars 4 times 1 plus R from the bond. And then we have to pay up. We have to pay either 8 or 2. And so what's the net? Well, the net at time 1 is going to be net at time 1. So this depends on if the random variable psi ends up being u. If psi ends up being u, then we'll have 4 1 plus r minus 8. Or if psi ends up being d, then it is 4 times 1 plus r minus 2. And if you look at the picture, the red line is big. and it does dominate. So in both cases here, we're ending up with something positive, right? So we pay nothing at time 0, and we get money. We get a strictly positive amount in the end. So this here is arbitrage. So free to enter, and gives us money at time t equal to 1 with no risk. So then one could ask, where else could I put the red line? So I cannot put the dotted line up here. Where could I put the dotted line? Well, I could try to put it down here. What would happen if I put the dotted line down here? If I put the bank down in the bottom, well, then we should swap things around. Right now, the stock is going to be the thing that you want to buy, and then you want to sell. You want to sell the bank account. So the only viable place that is left is to put this 4 times 1 plus r somewhere in between 8 and 2. So then we're left with these borderline cases. Should it be strictly, or should it be less than or equal to? And let me just spend a minute on this. So say that 4 times 1 plus r is exactly equal to 8. This was the borderline case that we might be concerned about. This is the suggestion. This is the suggestion. This is the difference between suggestion 1 and suggestion 2. That's exactly when you have an equality sign. So what happens if the dotted red line coincide with the top solid line? Well, as you see, the difference is in this strategy that we just went through is that you're going to get, so then at time 0, there's still zero net. And at time 1, what you have here in the strategy is that you're going to get 0 because these two now coincide if you have an up, and you're going to have 4 times 1 plus r minus 2. You're still going to get something. You're still going to get something in the down state. This is still arbitrage. This is still because you're not paying anything, and there is a chance of you getting money, and there's no chance of loss. There's no chance of loss, and a chance of a gain. So the case, this one here, the correct one is this one here. This is the correct one. And let me just write it down more formally so we can see it. So the general picture is that you will have your S naught, which will go up to S naught times 1 plus r, S naught times U and D. And then you will have this is my stock. And then I'll have the bond. The bond has to sit somewhere inside here. So it goes from S naught to S naught times 1 plus r. So the no arbitrage condition is that U dominates 1 plus r, which dominates D. So if 1 plus r gets to be too big, then the dotted line moves outside, it moves above the top line, And if 1 plus r gets to be too small, it dips below the solid line and you get arbitrage.
Question.
Yeah.
I remember the other example you were saying you don't want the dotted line to go below T1. Why? When time equals to 1.
Can you say that one more time, please?
The other example where you got 8 and 4.
Yes.
Yeah, you say you don't want that dotted line to go below T equals to 1, but you want it in between. When can it go below T equals to 1?
I mean, t equals to 1 is just a time point, right? This is on my time axis here. This is time.
Yeah, but the dotted line, you were saying something about drawing the dotted line
Yeah,
between 8 and 2, but you don't want it to go below
2.
2. Why?
Okay, so let's try to do the example. It's equivalent to saying that I don't want this dotted line here to dip below down here.
Why?
Yeah, why is that? What would you do? So let's go back to the example. Let's do this example here. So say, so this here is 6, 7. So let's do a 7.1. So say instead, and then you have the red line. This here is equal to 4 times 1 plus r. So this here is the bond. This one here is the stock. So can you create an arm? You're going to be buying one and you're going to be selling the other one. What do you want to buy? What do you want to sell?
Buy
Yeah, what do you want to buy?
the bond.
You want to buy the thing that goes. You want to buy the bond. This is the thing that's going to drop in value.
Drop in value. You want to buy the one that drop in values.
Really? You want to buy something that you know is going to get outperformed tomorrow.
But what about if you buy it and wait for it to isn't mature, then the price goes up?
Does the bond price go up in this example here?
So that means you want to. I don't know.
So again, we have the stock. Those are the solid pencil line. The stock has 2 possibilities. The stock can go up to 8 from 4, or it can go down to 2.
So you can buy the stock at 2.
Right, that's the stock. The stock is a solid one, and the red one is the bond. Right, so you can see in this example, like the stock outperforms the bond every time. So in such an example, would you buy the bond or do you want to buy the stock?
Buy stock at 2.
Okay, so you buy. No, you buy at 4. Right?
Okay, at 4. Okay, and sell at 8.
So you buy stock. Okay, so this is going to cost you. It costs $4.
Okay.
Times 0. And then you're going to sell the bond. You're going to sell 4 of them. You're going to sell 4 bonds. This is going to cost you. This is going to cost you 4 times the $1, right? Because each bond was 1. So this is going to cost me 4, also at time 0. Right, so the net effect, the net payment, right, is going to be, well, you have to pony up, you have to pay $4 and you're going to get $4. So the net effect at time 0 is 0. And then what happens at time, at the later time, right? So this here is at time 0, and this here is at time 1. So at time 1, then a bunch of things can happen. The net effect, the net payment, right? So what you're going to get, you have the stock, you paid $4 out here, you're going to get, well, you're going to get 8. If the coin flip is heads, but you also sold bonds. Okay, so you have to pony up the payment. So this is going to give you minus 4 times 1 plus R. But if this is the red line, 8 is going to be much bigger than 4 times 1 plus R. So this here is positive. And likewise, you own the stock. So if the coin flip is D, then we're going to end up with 2. And you still have to pay. You still have to pay the bond owners, 4 bond owners. The 4 bond owners, you have to pay them these 4 times 1 plus R. But if this is the picture, then 2 is going to be bigger than 4 times 1 plus R. So in this case, it doesn't cost you anything. And in the future, there are 2 things that can happen. In both cases, you end up making money. So that's also an arbitrage.
Okay.
Make sense?
Yeah.
Yep. So you see, there's not much room left. The only place that this can't happen is when you put it in between. Right. Then there's some chance that the stock is going to be more valuable than the bond, and there's some chance that the stock is going to be less valuable than the bond. And then you cannot play this game. Any more questions on this setting here? So again, note that there's no P here. This is there's no probability. Is this quantity here that doesn't appear anywhere in this equation. So this is our basic model. So we have in a binomial model, you're given U, D, and R, and they always satisfy this quantity. Sometimes you'll see, sometimes you will see one condition you will see is that 1 plus R is positive. This means that R is bigger than -1. And this ensures that the bank is always positive. The bank's value at time 1 is positive. But that has nothing to do with no arbitrage. No arbitrage is just this condition here, and there's no condition that says that 1 plus R should be positive. But sometimes you'll see that. Another thing that the textbook likes to do quite a bit, this is in particular the case that it sets the product U times D is equal to 1. This is most examples in our textbook. it gives prettier formulas when you have u equal to d. And you can see in the example we had here, this example, he already has it, like that 4 times u, that was u equal to 2, and then d would be equal to a half, and you have exactly that 2 times a half is equal to 1. So very often you'll see that, you'll see these properties here in the example. And this is, so this here is not no arbitrage. No arbitrage is this one. No arbitrage always should be checked. Make sure that you have parameters that satisfy this, otherwise there's something wrong in your model. Any other questions or comments before we move on? Okay, so the next thing we're going to do is we're going to price in such a model, in this particular model, we're going to move on, and we're going to start pricing derivatives. So as a model application, as a model application, we're going to price, we will price derivatives. And the derivatives we're going to be pricing today will be put, calls, and forwards. So you're given, so again, input will be U, D, and R, and then you're also given, a derivative. This is not a derivative like from calculus. So this is a payoff. This is a payoff at time 1 given by a function f of x. Okay, so let's do some examples. A derivative is a payoff that is given by a function. So these are inputs, and then your goal is going to be to create the price of the derivative, not at time 1, but at time 0. Okay, so let's try to think about how to do that. And let's do it in an example. So the call option would strike k has the payoff function f of x defined as x minus k positive part. So if you've never seen this plus up here before, let me write out what it means. It means that if x minus k is positive, so if x is bigger than or equal to k, then you're going to get x minus k. And if x is less than k, this is going to be negative, and you're going to get a 0. So this is called a hockey stick. Hockey stick. Because when you plot it, so out here I'm going to have x now. K is some positive number called the strike. So you have k here. And so you see when x is small, you're going to get a 0. So you're going to get a 0, 0, 0, and then it comes up like that. This here is x minus k positive part. So this is a hockey stick. That's the call option. these derivatives are given in terms of a payoff function, and different payoff functions are going to give you different derivatives. The call options, they're all given in terms of a constant capital K called a strike. And what you should note here is that this is always positive, right? There are no negative values. This thing is always positive. It's always non-negative. There's no value for X that will lead to a negative value to a negative payoff. This is always bigger than or equal to 0. So that was the call option. We'll do a numerical example when we compute the price in a minute, but let's just talk a little bit about the other quantities that we have. Another example is the put option. The put option, and this also has a strike. Positive strike price, K. And now the function f is something else. It's going to look very similar. It's going to look very similar to the call, but it's not quite the same. X and K, the switch roles. So here you're going to have K minus X, and you still have a positive part in there. Right, so this here is equal to, if it's positive, what I have in here, if it's positive, I'm just going to get the quantity. So this is if K is bigger than X. So when X is small, you're positive, and otherwise you're going to get a 0. So as before, it's a hockey stick, but this time when X is big, you're going to get a 0. So here we have a K, and you're going to be 0 out here, and then you're going to be pointing up like this, and then in here have K. So this is my X. So this is the put. This is the payoff of the put. And again, this is always positive. Should we say positive, or should we say non-negative to be more precise? Questions so far? The last one we're going to be playing with today is the forward, which already was discussed last time. A forward, we're going to be looking at a long one. A long forward with forward price. So now we get into this discussion about what we should call the strike. So let me call it a strike. Strike K. This is given as the payoff, which is just X minus K. And as we talked about last time, this is different. This can be both positive as well as negative. So it will look like this. This is both positive and negative. Both positive and negative values are possible. So it can be negative over here and positive over here. So from here on, this is my K. This is where we're positive. And over here, this is where we're negative. And remember, remember the definition of a forward price from last time. K is the forward price if the value of it will be if the value of the payoff at time 0 is 0. And you can see you can never do anything like that, like this definition down here will never work for puts and calls because you're always having these positive payoffs. Right? So this is always giving this implies a positive price or value, at time 0. You're guaranteed to get a non-negative number in the future. How much are you willing to pay for it today? Well, presumably you will have to pay something positive. But here it's different. This is a contract. I can give you a positive amount in the future and it can give you a negative amount in the future. Well, it should be possible to find a value at critical threshold such that the value of such a future payment at time 0 is 0. So these are the 3 contracts that I would like to price. Are there any questions before we get into some of the more? Yeah, and we're going to dive into calculations now on how to do that in this binomial model, but are there any questions before we get there? Any questions before we get there? Okay, then let me try to take you through an example where we price a call option. So the way that we're going to be pricing, so to find the price, the value at time 0 of say a call, what we're going to do is we're going to create what's called the replicating. This is also sometimes called the hedging portfolio. Okay, so what does that mean? We're going to have we're going to trade the bank and the stock, right? So we're going to hold delta naught units of the bank, and we're going to hold delta units of stock such that the value of our portfolio, and again, I'm going to start writing PF here for portfolio, the portfolio equals the derivatives payoff. This was this F composed here with the S1. Right, so remember what S1 was. This was the stock price at time 1. This is the stock price at time 1, right? And there are 2 possibilities. There are 2 possibilities. Here's one is going to be either is 0 times u, or it's going to be a 0 times t. Okay, so what we're going to be doing is we're going to be buying the money market account. We're going to be buying these bonds. We're going to be buying these bonds, and we're going to be buying and selling the stock. And one thing to note here is that these are quantities that are real numbers. We're not putting any restrictions on saying that delta has to be positive or delta naught has to be positive, or it has to be an integer, or it has to be a natural number. These are arbitrary real numbers, and we're going to create them such that by holding the portfolio, we're going to get exactly the same payoff as we do from the derivative. So remember that this here is controlled by this random variable psi. S1, you go from S0 to S1 by looking at this random variable psi if it is either u or d. So let's try to do this here in a specific example. So here's a specific example. We're going to be looking at a call with k being 5, right? So the payoff, this is my f of x. This was given as x minus 5 positive. And as before, we have our example, we have our stock. This was 4, and then it will go up to 8 and go down to 2. That was the stock from before, and then we have the bank. The bank will go from 1 to 5. So in this particular example here, u is equal to 2, d is equal to a half, r is equal to 25%. And we should make sure that there's no arbitrage. So does this leg here fit in between here? Well, yeah, we need to make it start at the same point. So we multiply here by 4. So if I multiply by 4, I'll start it here. And then I'll have to multiply this by 4. So I'm going to get a 5. So I take this red leg, and I want to look at how the red leg compares to the 2 pencil legs for the stock. So 4 and 5 is going to fit right in here. It's going to fit right in between 2 and 8. So we're good. This is arbitrage free. So how do we price this call? Well, we want to look at the call's payoff. We want to look at the call's payoff. The call is written on the stock with strike 5. So it's going to have 2 values. So instead of the 8 up here, what I need to do is I need to plug 8 into the formula. I need to plug 8 into F and figure out what that is. This is equal to, well, it'll be 8 minus the 5, which was the strike, and then I take positive part. This ends up being 3 positive part. This is 3. And now we're down here. This is 2. So I need to plug 2 into my payoff. This is going to be 2 minus 5. This is minus 3 positive part. This is going to give me a 0. So I'm looking at a payoff at time 1, which is either 3 or 0. This here is if psi ends up being u, and this here is if psi becomes d. And the big question mark is, this is what I'm talking about when I say as a model application, we will price derivatives. That word price derivatives, what that means is figure out what to put here. Now we know you're given what it is out here at time 1, but what's the value over here? What to put here at time 0? So we go back to what we had on an earlier slide. We're saying that to find this price at time 0, we create this replicating portfolio. So we create delta 0 and delta such that what? Such that holding delta and delta 0 will give me exactly the values 3 and 0. Right, so we get the replicating equations. So to replicate, so for these two to replicate, we need, well, let's have a look at it. What do we need? We need, if I invest, this is what's going to go into the bank. This here was the bank. And this one here was the stock. If I hold delta 0 units of the bank, then at time 1, I'll have the units in the bank times the bank price. The bank price was 1.25. And I also hold delta units of the stock. Well, so this is where I have to be careful because there are two possibilities. There's an up and a down. If I am in the up state, it's going to be worth 8. This here is when psi is equal to heads. And what do I want it to be? Well, I'm trying to replicate, so I want this to match up with the 3 here. Okay, so I want this to match up with 3. But there's also the possibility that psi is going to be d. Well, in that case, if I have delta naught units of the bank doesn't care what psi is. It's always the same. There's only one leg on this picture. There are 2 legs over here. There's one here. There's always 1.25. Now, on the other hand, the units in the stock, they're not going to be worth 8. They're only going to be worth 2. So this is going to be the value of my portfolio if psi is equal to d. Okay, so what is it going to? I want it to be 0. I want to be able to replicate. These are my replicating equations, and as you can see, there are two. There are 2 because we have a binomial model. There are 2 equations. That's because psi takes 2 values, and there are 2 unknowns. Well, the 2 unknowns. This will be my delta and delta naught, and this is because there are 2 traded securities. This will be the bond and the stock. So I have a system here, 2 equations and 2 unknowns. I could solve. So we solve the equations. Solve the 2 equations. And I'm hoping that everybody has has tried to solve two equations and two unknowns before, did two linear equations and two unknowns. But one thing I did want to show you, one of the goals that we've had with class around is to make the class more focused on using computer software. And since this is something that we're going to be doing a lot, let me just try to show you how to solve two equations and two unknowns I'm going to use Mathematica. Let me just try to show you how to solve it in Mathematica. Are there any questions before I start showing you how to do that in Mathematica? Are there any questions about this before we do Mathematica? So this, what we're seeing here on the right-hand side, these ones here, this is the payoff. This is the derivatives. And what we're seeing here, this is the portfolios payoff. And we match them up. And now we're going to try to solve for the two equations. And let me show you how to do that in Mathematica. I do trust that we can all solve them by hand, but for those of you that have not played with Mathematica before, can you guys see Mathematica now on my screen?
Yeah, we could see it.
Okay, so let me try to show you how to do it if I can get it to work. So you write solve, right in there was a delta, I call it delta naught, and then it was times 1.25. Delta naught was the units in the bank. This interest rate, the value of the bank account at time one was 1.25, and then delta times 8, this was the stock in the upstate. Then you put two equality signs, and then I want that to be equal to 3. And the other thing I want, this is my second equation, the first part doesn't change because the bank account is always worth 1.25 in the no matter what the stock price is. But the stock price, it goes down to 2, and the payoff, the calls payoff is going to be 0. So those are my two equations. Then I write the variables that I want to have solved for. This is delta naught and delta. And I solve this thing and cross my fingers that it's going to work. And it doesn't. So let's just do a test. Times 5 0 x here. Okay, something is wrong with my Mathematica. Can we try this one more time? Try to share this one. Alrighty, can you guys see my Mathematica screen again?
Yes.
Good. So let's try to change this up. So now it's giving me a solution to this example. Let me try to do this one more time. Delta 0 times 1.25 plus delta times 8 equals 3. Do a pit stop here, make sure that it works. So see, if I just had one equation and asked for it to solve for delta, then I'm going to get the solution in terms of delta 0. But I have two equations. And the other one, so again, the money market account doesn't change. this one here changes to a 2, and the payoff changes to a 0. And here are my two values. So delta naught is minus 0.8 and delta is a half. So let me write that on my document camera. You might still be able to see it up in the corner. So I'm going to get delta 0 is minus 4 divided by 5. And delta is half. So you can see this is fairly easy to do in Mathematica. And it's handy because we're going to be changing, we're going to be looking at different derivatives in just a second, and then it's handy to have it available. So now I know what to invest. I need to buy minus 0.8 shares in the bank, and I need to buy half a stock to create this derivatives payoff. And so what is the price of the portfolio? Price of portfolio at time 0. Well, the way that we do that is how much does it cost to buy delta naught? Well, what is the price of the bank at time 0? The price of the bank at time 0 is 1. So I'll have 1 times delta naught. How much does it cost to buy a stock? It costs $4 to buy one stock. 4 times delta. And then I'll plug in, this will be minus 4 over 5 plus 4 times a half. And this here comes out to being 1.2. This is my question mark. I can now eliminate this question mark out here. And I can put 1.2. This was the answer we were looking for. What is the price of a call option with strike 5? Are there any questions on this part? So we should of course say here that this number here, this depends on k being 5. In particular, I could try to change it to 6. If I were to change it to 6, then what would happen? If instead of k equal to 5, I will do it k equal to 6. Try k equal to 6. How would it change? Well, this part here is exactly the same. So what's going to change is the call price increases. Okay, so the call price increases. This is the conjecture. Let's go through the motion and see what happens. All right, so if you go from 5 to 6, then what's going to change is the payoff function, right? Your f function is going to change. Instead of 5 here, you'll have to have a 6. So you'll have to have 8 minus 6. So that's a 2. And you have to have 2 minus 6 positive part. That's still a 0. So you're going to have 2 here, and you're going to have 0 still here. Okay, so you go back to the Mathematica code. So we're going to go back to the Mathematica code. I'm not interested in solving this one anymore. I will solve the one where I have 2 here. And I'm still going to have a 0 here. I'm going to solve for my new ones. And then we just copy paste them again. It's going to give me delta 0 is equal to minus 0.533, and delta is equal to 0.33. Right, and so how do we get the price? We're going to get the price by saying how much does it cost to buy this many units in the bank. So it's this thing times 1 plus, and then it's you have to buy a third of the share of the stock, and the stock price was 4. So this is going to be the value. This is going to be the value of the portfolio times 0, and it's 0.8. So this is going to give us a call price times 0, which is equal to 0.8. So did the price go up or down? Did the price go up or down? The call price, it does not increase, the call price decreases. So different strikes give you different call prices. And indeed, we could look at K's instead of being 5 and 6, we could take a K that's like equal to 100. What would happen? What would happen in these extreme cases where we take K equal to 100? Try K equal to 100. What's going to happen then? Well, if K is equal to 100, so now I have X minus 100. What's going to happen is F of 100 is going to be 8 minus 100. And so this is minus 92 plus the part. This is a 0. So I'm going to get a 0 here. I'm going to get a 0 down here. So what's the call price going to be when the payoff is always equal to 0? So we're going to get a call price of 0. And likewise, you can move it into the other direction. If I would start having K to be equal to say 0, then what? If I moved it into the other situation where I'm dropping this thing here to 0, then I'll have just X positive part. And then what will the payoff be? Well, it'll be 8 minus 0. This is equal to 8. And 2 minus 0, that's equal to 2. And so what's the payoff? So we're going to get the payoff 8 and 2. And what's the payoff? What is the value of the payoff 8 and 2 at time 0? Well, 8 and 2 is exactly the stock, 8 and 2. And what was the value of the stock at time 0? Well, the value of the stock was equal to 4. So you're going to get call price at time 0 equals to 4. These are just some, these last two here, they're just the extreme cases where we send the call price up to a very high level, or we send not the call price, we send the strike price up to a very high number, and we send down to a very low number, and we're going to get these extreme values, 0 and just the stock price itself. But as you can see, when you're around 5 and 6, well, it goes from 1.2 down to 0.4. So it's not like it's linear in K. This is not the case. Yeah, are there any questions? Are there any questions?
I had a question regarding Mathematica. How did you enter the delta symbol?
Yeah, so this is tricky, right? The way that you do the delta in Mathematica is you hit escape and it creates this symbol there. And then what you can do is you can either write delta And then you have to end up with escape again, and it makes that symbol. When you start using Mathematica, you will know that a capital D, this is actually good enough. You can also do like a little d, then you get a small delta. And this the psi that we were looking at, that was that random variable there that I've been writing earlier. This is this curly letter. And the other thing you want to know is that for Mathematica to compile, it's not enough to hit enter. If I just hit enter here, it doesn't do anything. But if I hit shift and enter, it compiles. Another thing to look out for, which is a typical source of mistake, is when you're asking for equalities, you can either use 1 or 2, and you can see here, there are 2. And this is when I'm trying to get it to solve equations. Whereas if I were to say, I want psi here to be 7, I'll just put 1. You might have seen, you see me write this. This is my notation for definition. This here is Mathematica's notation for definition. And then this is Mathematica's syntax for equality, 2 equalities. If I just do this, what it then means is that my psi is equal to 7. If you're used to programming in other languages, one thing to look out for with Mathematica is that it runs on global variables. So this can be quite frustrating if you're not keenly aware of it. This is one prompt, right? So I would start a new prompt over here where I'll do something else. But you see, if I call in a new prompt, if I call what the variable psi is, it's also 7 in my new prompt. So this is just something to be aware of. It runs on global variables. It's not like that new prompt I have over here that it'll reset all the variables. It doesn't work like that. If you want to do that, you have to go up and quit the kernel. Could you see any of this, or did it not appear on your end?
No.
Let me do it again. So this is going to happen quite some time. This is going to happen often. So let me try to do this. So when it happens, just let me know that you can't see what's going on. It's okay. So let's try this again. So can you see my Mathematica screen now?
Yes,
Okay.
we can see it now.
So one thing to look out for to get started. So you hit delta, it makes these 3 curly signs right there. And then you write, if you want to have a delta, you put in a capital D and you can write delta like that. And then you end up with escape. Escape makes these 3 dots. You can also, when you get used to it, you just have to write a capital D and then end up with escape, and it makes the triangle, the capital delta. And then what I was saying was that inside Mathematica, when you solve equations, you need to have 2 equality signs. If you want to have that, if you want to define stuff, you use 1. So if I want to have my psi to be 6, I just use 1. And it gives me psi is equal to 6. So when I call psi down here, it's a 6. Whereas if I do 2, it will ask if psi is equal to 9, and then I'll get a false. When psi is not equal to 9, it's equal to 7. So the 2 equality signs, this is what we would normally use as 1. And then my notation for a definition, this is what Mathematica just used for 1 equality sign. And the thing I was saying in the end is that now I define psi here to be 6. And if you open up a new prompt, so if I open up a new prompt, you won't be able to see this new prompt before I go back and share this new prompt with you. So let me do that. All right, so now we can see my new prompt that is empty. And the thing to look out for is that if I call psi over here in the new prompt, it's still equal to 6. And so that means that these are global variables. It's not like you open up a new prompt and then the memory has been reset. You can just use variables however you want. You have to look out for what you've been defining earlier in different prompts. And even if you turn on and off your computer, Mathematica will store all these variables. So you have to clear them. And the way that you clear them, if I can get Mathematica Zoom to share that, is, I'm not sure you guys will be able to see that. Yeah, you can't see that. It's inside Mathematica. There is a, up in the top part under evaluation, there is a button that says quit kernel. And so you have to go, when you use Mathematica on a regular basis, you will have to go in, hit this button that says quit kernel. It will clear the memory, and then you can refresh and start using these variables again. Okay, I hope you could see it this time. Are there other questions, comments?
What was the quick key for the psi?
So you hit escape. It creates these 3 lines. And then you write XI. And then escape again.
Okay, I see that.
Okay, if there are no more questions, then I suggest we take a little break. And then in about 10 minutes or so, we get back together. We will do examples with the put and with the forward. You have to change Zoom link now. So log out of this Zoom link that you're in, go back onto Canvas and click the next Zoom link. And we're going to be back in about 10 minutes.